Shubho Navavarsho, welcome friends, wishing you all a very happy and healthy new year. So this year may all of us be able to attend offline classes at school and get good marks in every single exam. So in the previous videos we have seen that how a transistor can be used or can act as a switch, how we can turn it off, on in a circuit, and also how they can be used to make digital logic circuits. We have also seen how they can be configured to act as memory storing device, that is flip-flop memory unit, right? So today we shall see another extremely important characteristics of transistor, that is current amplification. Sorry, I have to sometimes do like this because I have got my braces and it's hurting a lot, so I might not be able to even smile or speak loudly for a while. So yeah, anyways, so if a small potential is applied across the base and emitter of an NPN Bipolar Junction Transistor, a much larger current can flow from the collector to the emitter, right? We shall also find out the threshold or what is a junction voltage, and today we will do everything quantitatively, that is we will measure voltage and current, right? So we will use the BC547 NPN-BJT in the common emitter configuration. That is, the emitter will be grounded because it is common. Whatever is common, it will be grounded, and the base and collector will be applied to positive potential or VCC. So let's start. Okay, so now we will start drawing the circuit diagram. So first of all, we will draw the transistor. Then we will label it. Alright, and since it is a NPN-BJT transistor, so it will be, the arrow will be outside for the emitter. Now for the collector, it will be connected to the VCC, right? It will be connected to the VCC, okay? And the emitter will be grounded. We will also add an ammeter here. Now for the base will be also joined to the positive potential. Alright, and we will also connect a voltmeter to measure the potential difference across the base and the emitter. So this will be the voltmeter or potentiometer, and to vary the voltage we will add a variable resistor over here. Alright, so now we will join these two because both of them will be in the same positive potential, that is the VCC, which is approximately 5 volts, right? And the current will flow from the positive potential to the collector of the transistor and then to the emitter. So this will be the current flowing through collector and emitter, okay? While here in the base circuit, the current is flowing from the base to the emitter, right? So this will measure the potential difference between base and emitter. So basically we are finding out the relation, right? This is the collector this is the base and this is the emitter. So we are going to find out the relation between these two. What are these two? The voltage or potential difference between the base and emitter vis-a-vis the current flowing through the collector and emitter. So this will be the circuit diagram for the first experiment. So now let's do it practically on the breadboard. Let's start. Okay, so first we will have to make the variable resistance. So for that we will make a resistance shack. So what is that? We will take we will take many resistors and we will join them in series. Okay, and we will have various type of resistors like 1 million ohm resistors, 100,000 ohm resistors, 10,000 ohm resistors and 1,000 ohm resistors. So first of all we will take the 1 million ones. Here we have, and we will join them in series as I said. So here we have the first one. Then on the same hole in which the first one was there, the second one goes in, leaving one column gap. We again give the next hole. So like this we continue. So we are done with the first round, which is the 1 million ohm resistance. Now we will take the 100,000 ohm resistance. Now these two parts are ready. Then we will do 10,000 ohms. There you go. Now we will do the last remaining part, which is the 1000 ohms resistors. So now our resistance shack is ready. So now we will keep it aside. Okay, so let's begin. First of all, let's connect the transistor. Then we'll do all the connections. Alright, so now you will see I have also marked the anodes and cathodes of the ammeter and voltmeter. Now another important thing is that I don't have an ammeter or voltmeter, so instead we are using two multimeters. Alright, multimeters can measure or act as both like ammeter and voltmeter. So you can see with a white knife marked, the single markings are for ammeter. The single marking is for the collector emitter current measurement. Alright. And the double markings, as you can see here, two markings in this one and in this one, are for the base emitter potential difference measurement. Alright. So now let's start analyzing the circuit. First of all, from the positive potential, from the VCC, we are going through this red colored wire to one of the anodes of the multimeter, while the other end, the cathode, is connected to the collector. Okay. Now from the emitter, this yellow wire comes out, and at the same row, this white wire is joined to the ground. Alright. and on the same row again a red wire comes out to the second multimeter's cathode. Okay. Now for the base, if you see, a yellow wire comes out in a certain row. In that same row we have this blue wire connected to the resistance track, and through that is connected another wire to the VCC. Alright. And in that same row we again have another orange colored wire which is connected to the anode of the second multimeter to measure the potential difference, right? And the other end of this multimeter is again connected to this row from which the emitter is also joined, so that we can measure the voltage across the base and the emitter. Alright. So this is the whole circuit. Now we shall start taking the datas. Okay, so now that our setup is ready, first of all we will give power. I have connected the power supply to this circuit, and as you can see, this one is to measure the voltage and this one is for the current. So we will switch them on, and I have made a table in which I will write down the voltage across the base emitter circuit and the collector emitter current. So that is this one and this one respectively. So first of all I have given 10 million ohms. So let's see, for voltage and for current, right, so it is showing like this. So first we will take down the value in my copy. So I will write down that the voltage here is 0.02, current is 0. Alright, now I will shift the wire to get 9 million ohms. Like this I will continue unless some value comes in the current. Okay, so we are getting some change at 615 volts. So now we are getting the values in our table, and we have got some values. I'm going to adjust the units. As you can see that approximately at 600 millivolts, that is about 0.6 volts, we are getting some value. So we have done successfully the first experiment. So now let's plot it on the graph. Okay, so for the first experiment, I'll draw the graph on my graph paper. So on the x-axis we will have the potential difference or voltage, and on the y-axis we will have current, because potential difference is a variable dependent variable. So here we will have the voltage across base emitter, and here we will have the current through collector emitter. Okay, this is y. So now let's plot. Alright, so this is what we are getting. So let me mark them permanently, or rather more distinctly, so that you can see where the points are. I hope you can see them. So these are the points, right? So when I join them, it's like this. right? So we are almost getting this type of shape, right? So we have got the graph. Now if you see carefully, we have three regions. One part is this, one part is this, and one part is this, right? So this region has a increase in the amount of current. So this region is called the active region. Why? Because there is active change throughout the graph. This region is called saturated region. Why? Because after reaching this level, it is the same, right? It is continuing at the same position of current. There is no more change in the level of current. So it is called saturated region because it gets saturated at this level. While this region is called the cutoff region. So the cutoff region ends at about 0.7 volt, right? So we have actually found the junction voltage. Now what is the junction voltage? Junction voltage is the point at which there is change in the graph, that is cutoff becomes active region, right? So this region is called cutoff region. Let me write it. Cutoff region. Alright. So the first experiment is successful. We have found out what is there. And also this region, that is the active region, is used for amplification. Why? Because there is gradual increase in amount of current. So if we use it as an amplifier, we will slowly get amplified current. So transistor is used as amplification in active region and as switch off and on in the saturated and cutoff region. Okay, so this is for the amplification, active region. Okay, so now let's start the second experiment. So now for the second experiment, the circuit diagram will be, first of all, let's draw the transistor. Now for the same circuit diagram, we will also join or connect the positive potential to the collector. Alright, and here we will also place an ammeter. Okay. Now for the emitter also it will be the same. It will be grounded. Why? For the same reason, because it is the common emitter configuration. Whichever is common will be grounded. And as for the base will also be connected to the positive potential. But this time there will be a small difference. Why? Because we will also be measuring current in this circuit. So we will also add an ammeter, unlike previous time where we had added a voltmeter, right? But also to vary the current flowing in the base circuit, we will add a variable resistor. Okay, now let's join the positive potential. So now our circuit is ready, and in this experiment we will be finding out the relation between the current flowing through the base emitter circuit vis-a-vis the current flowing through collector emitter circuit, right? So this is what we will find out. So in the collector emitter circuit, we are also measuring the collector emitter current, and the base emitter circuit also we are measuring the base emitter current. Alright, so our second circuit diagram is also ready. Now let's do it practically on the circuit board. So let's start the circuit for the second experiment. So first of all, as you can see from the positive potential, we have connected this red wire to the anode of one multimeter, and of that same multimeter the cathode is going into the collector, right, of the transistor, while the emitter is grounded. Okay, so the current flowing through the collector emitter circuit is done. Now for the base, you can see I have directly connected the base to a resistance jack, through which we have this white colored wire joined to the cathode of another multimeter, and of that same second multimeter, because both of them are marked single, we have connected it to the VCC. Alright, so the emitter is grounded, the base is also done, and the current is going to flow smoothly now. The circuit is ready. So now let's take in the values for the second setup. Now let's start doing the second experiment, data value collection. Okay, so we have here, and we will measure both current, right? So let's do it. Alright, so here is my table after adjustment of the units, and I have more of the values in the next page. So I have got the ratio. Now I have to plot it on the graph and show it to you, and so that we can see what happens on the graph. So let's start. So now for the second graph, in the similar manner as we did in the first graph, we will continue to plot the x and y axis. So on x axis we will have collector emitter current, base emitter current, and in the collector emitter we will have the y axis. So let's do it. Okay, we have actually got almost the same figure, right? We actually got even better than the first experiment. Like this we have got. So we know that this is the active region used for amplification, right? And this is the cutoff, and this is the saturated. Now if you see, according to my markings, the ratio is coming exactly 100 times. How? For like suppose according to my table which I have got, if you see my table, if we divide it, it is like 0.1 and 10, right? So if you divide them, how much do you get? You actually do get 100. So 100 times it is getting amplified. So we have actually got our beta is 1:100 amplification. So the ratio of amplification is 100 times. So our second experiment is also complete. We have successfully done both the experiments. That was really amazing, wasn't it? So now suppose if the base emitter current is varied, then the collector emitter current will also vary in the same manner but with greater amplitude. This is how a varying electrical signal can be amplified. This is how it works. And this property is often used in devices like a radio transceiver. You might be wondering why I'm using this radio transceiver right now. It is a walkie-talkie, right? Basically. Well, if you want to know, you can call me in my ham license. That is, I am a amateur ham operator, VU3EGC. That is VU3 Eco Golf Charlie. And I am getting ready for the 18th April World Amateur Radio Day. So yeah, thank you all so much for today. I hope you enjoyed today's experiments a lot, and see you soon then. Bye bye.